Physics Part 403. When the envelope is stretched, the length of the wire increases and its diameter decreases slightly. Increase in the length and decrease in the diameter both cause the resistance to increase. Now it's your turn. Draw a sketch of graph to show the variation with temperature theta of the resistance R of a thermistor. Mark typical values on the axis of your graph. Number 2, state what is meant by the piezoelectric effect. B, describe how a quartz crystal may be used to provide an electrical signal that is dependent on the sound pressure incident on it. We've got section summary for you. Number 1, sensing devices are used to detect changes in the environment or the properties of a body. Number 2, in general, the change being monitored causes a change in electrical property of the sensor. Number 3, frequently used sensors include the light-dependent resistors LDR, the thermistor, the piezoelectric transducer, and the strain gauge. Number 4, the resistance of an LDR decreases as the light intensity on it increases. Number 5, the resistance of a negative temperature coefficient thermistor decreases with increasing temperature. Number 6, a piezoelectric transducer converts variations in pressure, such as due to a sound wave, into variations in voltage. The strain on a metal wire, strain gauge, is proportional to its change in resistance. Section questions. Number 1, suggest suitable sensing devices to detect changes in sunlight, in the width of a crack in a wall, in the weight of water in a tank, in the temperature of the oil in an engine. Question number 2. Describe how a sensor may be used to count the number of mice that pass through a small hole in a wall. Section 2, processing units. At the end of this section, you should be able to show an understanding that the output from sensing devices can be registered as a voltage. You should be able to recall the main properties of an ideal operational amplifier, op-amp. You should be able to deduce from the properties of an ideal operational amplifier the use of an operational amplifier as a comparator. You should be able to show an understanding of the effects of the negative feedback on the gain of an operational amplifier. You should be able to recall the circuit diagrams for both the inverting and the non-inverting amplifiers for single signal input. You should be able to show an understanding of the virtual earth approximation and derive an expression for the gain of inverting amplifiers. You should be able to recall and use the expression for the voltage gain of inverting and non-inverting amplifiers. The change in the physical property of a sensing device must in general be processed in some way before the change can be displayed or measured. The process is carried out by a processing unit, which is some form of electrical circuit that is connected to the sensing device and provides a voltage as its output. If the voltage is small, then it may be necessary to amplify it. The voltage can then be used to control an output device. The potential divider. A potential divider circuit enables a change in resistance of a sensing device to be converted into a voltage change. In figure, the device The sensing device of resistance S is connected in the series with a resistor of resistance R.